All right, hello. This video is over Bohr diagrams. So if you are following along in the notes, this is notes 3.4 Bohr diagrams, or page 5 of the notes if you're looking at the original big list. Yeah, we're going to talk about Bohr diagrams. So Bohr diagrams are keyed into a different aspect of an atom. Up to this point, we have been talking about mostly the nucleus. We've talked a little bit about electrons and ions, but not a whole lot, other than just, hey, this is how you calculate the ionic charge. So we're going to talk about Bohr diagrams because Bohr diagrams give you a general idea of what the electron shells, or not the electron shells, the electron cloud actually looks like. So again, I mentioned this before. This kind of model that we're looking at is a mix between Bohr's planetary model and Schrodinger's quantum model. Schrodinger's model mainly just contributes the term electron cloud. And Bohr is the model we're actually going to be using. So we're going to be picturing the electrons as planets orbiting around the sun. However, there's more than one planet in every orbit in this particular model, and we'll talk more about that as we start drawing out some diagrams. So yeah, Bohr diagrams, the primary purpose is to show you what is happening in the electron cloud. Where are the electrons? Why do atoms bond the way they do? Well, it has to do with how the electrons are actually arranged, and it's why 100% we will do nothing with, when we start talking about most common ion, we will do absolutely nothing with anything in the D block or F block because they do not follow these rules. And that's all I'm going to say on that because they're complicated. You don't want them. Just don't worry about those. So we're only going to be talking about stuff in the first two columns or the last six, which are called the S block and the P block, FYI, in case you care. The S block is two rows wide. It's the one with hydrogen. And the P block is six columns wide and 2 columns wide. When we draw a Bohr diagram, we put P equals and N equals down in the middle of the notation, and then we draw circles around it to indicate all of the layers of electrons. And that's pretty much it until we actually start drawing some. There is one thing I want to mention. There are a couple different terms that can be used to talk about electron orbitals, electron shells, energy levels. All of these are talking about the same thing. You need to recognize that. If I say energy level, I'm referring to the orbits around the nucleus. If I say electron shell, I'm referring to the exact same thing. Orbital, electron shell, energy level. They all mean the same thing, and I'm going to use them interchangeably. And honestly, depending on how old whoever you're talking to is really going to determine which one you're hearing. So be aware of that. You are going to hear all three constantly. So be ready for that mental gymnastics of switching back and forth. So first and foremost, there are 7 energy levels. Well, there is a maximum of 7 energy levels that an atom can have. And we are going to be assuming that all atoms are in what is called their ground state. That doesn't matter for you guys, but just a quick aside. So an atom cannot have more than 7 energy levels so far. That's important, so far. So based on the elements that are currently on the periodic table. So the number of electrons that can be in a particular energy level vary depending on what energy level we're talking about. So the first energy level That's what capital E with a negative sign is the abbreviation for energy, if you didn't know that. First energy level can hold up to 2 electrons. Second energy level can hold up to 8. Third, also 8, because, of course, 4 and 5 can both hold up to 18, and 6 and 7 can hold up to 32. You need to know at least the first 4 of these numbers, 2, 8, 8, 18. In this class, aside from one of the things we're going to go over in this video, you're not going to need anything bigger than that. But you will need 2, 8, 8, and 18 at some point. So, FYI, if you're not going to memorize the entire list, you need to know the first 4. Okay, 2, 8, 8, 18. 2, 8, 8, 18. Memorize it. You have got to know it. This is not on the periodic table somewhere. You have to know. 2, 8, 8, 18. Okay? Cool. Now, we are going to draw a Bohr diagram because this is, frankly, the easiest way to really explain what the heck is going on. So we're going to draw a Bohr diagram for calcium 42. So I'm going to write that up. Actually, I'm going to write that over here. So calcium 42. This, by the way, in case you forgot, is an isotope notation, longhand isotope notation specifically because it says the name. Okay, so we're going to draw a Bohr diagram for this. So first thing we have to do, if we're drawing a Bohr diagram, is we need to take care of the nucleus. Okay, so we can determine the number of protons and the number of neutrons with what we have here. Because this is calcium, that means it has to have 20 protons, because calcium means 20 protons. That's what makes calcium calcium. That should be reviewed. So I'm going to just write roughly in the center of this work area here, I am going to write P equals 20. By the way, I would not try to write this or draw this as I go. I would wait until I finish and then write it down. Okay? So don't try to write this right now. Just follow along and then copy down the answer for the sake of your own sanity. Okay? So P equals 20. Okay? Because calcium. Now, how many neutrons are there? Because right under P equals, we need N equals. Well, how many neutrons are there in this atom? How do we figure that out? Well, this number right here is not the number of neutrons, but it is the mass number. And as you guys are all quite familiar, based on the entirety of the last, 7 days of class, the mass number is equal to protons plus neutrons, or the number of neutrons is the mass number minus the number of protons. So 42 minus 20 gives us 22. So there are 22 neutrons. So I'm going to write 22 here. Okay? So that says P equals 20, N equals 22. Don't write yet. I'm just showing you that that's what that says. Okay. Now, around this nucleus, because this here is our nucleus, around this we are going to draw a circle. This circle represents the first energy level of the atom. Okay? And I almost ran away without mentioning this. For now, we are going to assume that all atoms are neutral. Okay, neutral means that P equals, not N, good Lord, E. The number of protons and the number of electrons have to be the same in order for an atom to be neutral. So we're going to assume this for everything we do today and probably tomorrow. So, yeah. So that means we need 20 electrons. Well, this circle, because it is the first energy level, can only hold 2 electrons. So we're going to put 2 electrons in it. Now, this is kind of up to you how you want to do this. Some people like dots. That's fine. Do not put X's. If you want to put dots, that's fine. I've had some people put circles. Do not put X's, because eventually you're going to be writing in pen and you're going to have to cross something out because that's going to be the assignment. And if you're putting X's, we are not going to be able to tell what electrons you're marking out. So do not use X's. You can use dots, you can use circles, or the way I personally learned it was E's. So I'm going to literally write E's, okay, with little minus signs. Okay, and notice they're on opposite sides. I didn't pack both of them in together. So I didn't go, oh, there's one and oh, there's the other. No. Because electrons are negative. They repel each other. So they stay as far apart as they possibly can. And unlike protons, they actually can. They can move away from each other because they can, move. So they're going to be separated. So don't pack them all in one spot. Spread them out in your diagram. So we have filled this energy level. We have accounted for 2 electrons, which means we still need 18 more. And by the way, I recommend doing this to help yourself keep track of how many more E's you need, especially when you start doing stuff that's got more than 2 energy levels. So we need another circle. So I'm going to draw another circle here. And this is the second energy level. Being the second energy level, it can hold 8 electrons. Well, I need 18, so I'm going to fill this one too. And once again, I'm going to spread them out. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. Minus 8 leaves me with 10 more. Well, any guesses? If you said add another circle, you are correct. And this one also holds 8. So we're going to put 8 more E's, 8 more dots, however you're choosing to do it. And we are going to continue to spread them out. Okay, that's another 8. We only need 2 more. Well, where do those 2 have to go? Well, they go in the 4th circle. So I'm going to draw a 4th circle. But this time, I am not going to fill it. The 4th energy level holds 18 electrons. But I don't need 18 electrons. That looked like a 3 for a second. I only need 2. So I'm only going to put 2. And I'm going to put them on opposite sides. And ta-da! That is a Bohr diagram for calcium-42. I have accounted for all the electrons. They're drawn around the outside. In the center, I have P equals 20, N equals 22. I'm going to move this up closer. And if you want to try to sketch that, you can pause this. You've got about 3 seconds here before I'm going to back it up and erase. All right. Okay, cool. Now I'm going to erase this. Well, actually, before I get ahead of myself, I want you guys to now do, on your own, pause the video. If you're watching this on your own, pause the video. I want you to do neutral oxygen 15. Okay, so it's neutral, just like the last one, but instead of calcium 42, this is oxygen 15. Okay, oxygen 15. Draw it. I'm going to put the answer up here in a second, so figure it out. Started scratching my eye as soon as I hit play. All right, so oxygen 15. Obviously, we're going to start out by saying that P, by the way, I'm about to show you the answer, so hopefully you've drawn this already. All right, cool. Okay, so P this time is equal to 8 because oxygen. N is going to be 7 because 15 minus 8 is 7. And this one is going to need 8 electrons, so I'm going to go 1 circle with 2 E's and 2 circles, but again, 8 minus 2. I don't need all 8 of the electrons that this energy level can hold. I only need 6. So I'm only going to put 6 in it. So 1, 2, 3, 4, 5, 6. And that is the answer. Yes, really. Okay, and the last thing that I want you guys to do, and I'm not going to draw this because it would take the entirety of this board to do it with an expo marker. But I will have it on my board in my room, so you can check it there. The last one I want you to do is lead 209. Now, the reason I want you to do lead 209 is because you need to practice a larger atom. I am never going to have you do something as big as lead 209 again, but practice it. You need to work on high numbers, okay, making sure you're spreading the electrons out. Get the practice done, and that's it for today. So, that's all. This video is a little longer than I thought it would be, but oh well. Have a wonderful night, and I will see y'all next time.